Come on guys, let's check out Kubernetes architecture today. This is the architecture of Kubernetes. We have two planes here. One is control plane, another one is data plane or node plane. First, let's check out the control plane. Control plane is like boss in Kubernetes. It makes all the big decisions, like where to run the applications and what to do if something goes wrong. We have four components in control plane: Kube API server, scheduler, controller manager, and etcd. Let's check out each of these components in detail now. Kube API server is like front desk or receptionist that handles all the requests. So Kube API server is the only way to interact with the Kubernetes. So user talk to API server using the REST APIs. So you can use kubectl or any other tool to send a request to Kube API server. So that request can be creating a pod or some other requests. So then API server will check whether that request is valid or not, like you have the correct permission or not. So once the correct permission is there, then it informs the other components of the Kubernetes. So in short, Kube API server is like a receptionist. It coordinates everything while ensuring all the rules are followed. Then the second component is scheduler. Scheduler is responsible for deciding where to run the applications. Here scheduler is like a smart matchmaker. It will ensure that each pod finds the best worker node to run. Let's see how the scheduler works. So first step is pod creation. When you create a pod, it doesn't immediately know where to run. Second step is scheduler steps in. So scheduler looks at the pod's resource needs, constraints and the labels. Third step is scheduler evaluate the nodes. So it checks all the available nodes in the cluster and filter out those that don't meet the pod's resource needs and have the rules or taints that the pod can't tolerate. The fourth step is scheduler scores nodes. Among the suitable nodes, it assigns the scores based on available resources, node affinity or anti-affinity and network proximity. The final step is assigning the node. So the scheduler selects the best scoring node and it also updates the pod specification. Like this pod is bind to this particular node. So here scheduler is very important to balance the load. So load balancing is very important feature of scheduler. So in short, scheduler is smart matchmaker. So it ensures every pod will get the best possible home. So next component is controller manager. So controller manager is like a multitasking supervisor. It ensures that every task in the cluster is running fine. Actually, the control manager will constantly watches the system and fixes the issues, and it ensures that the desired state is matches the actual state. Actually, control manager will manage the different controllers. Here each controller looks after a specific resources like pods, nodes or services or etc. For example, controller like node controller, it monitors the health of the worker nodes and takes action if a node goes offline. Similarly, replication controller, so it ensures that the correct number of pod replicas are running. Similarly, there are other controllers and control manager will manage all these controllers. So first function of control manager is it manages all the controllers. And the next function will be the automation. So it will automate routine tasks like scaling the pods, restarting the failed pods or cleaning up completed jobs. All of this will be automated by the controller manager. So this is how the control manager works. First it will watches the cluster. So it continuously monitors the cluster state using the API server. Then it compares states and it will check if the actual state matches the desired state specified in your configurations. Your configuration will be like deployment files or any other files. And third step will be it will take the action. So if there is a difference between actual state and desired state, it will take the action to fix that. So if a node fails, the node controller will remove it from the cluster. And if a pod is missing, the replication controller will create a new pod. So in short, control manager is a multitasking supervisor. It is like behind the scene hero of the Kubernetes. The next component is etcd. This is like a brain of your cluster. So etcd is a distributed and it is a key value store. It keeps all the critical data needed for managing the cluster. It is like database for your cluster and it stores the data in key value format. So now let's see how it works. So first step is it is a central database. Means etcd stores the desired state and actual state of your cluster. Here desired state means what you want and the actual state means what is happening, and etcd stores both of these states. The second step is interaction through Kube API server. Here the Kube API server is the only component that communicates directly with the etcd, and other components like scheduler or control manager interacts with this etcd via the API server. Then the actual function updates and reads. So when you create or modify the resources, the Kube API server updates the data in the etcd key value store. Then anytime scheduler, control manager and other components reads data from this etcd store and it will ensure the cluster operates as desired. So here etcd is the single source of truth. So without this, Kubernetes wouldn't know the state of the cluster. So it is responsible for storing all the important data about the cluster, and without etcd, the cluster simply wouldn't function. So those are the component of control plane. So next see the data plane or worker node plane. These nodes will take the order from the control plane and do the actual work of running your application. And here each node will have three main components: kubelet, container runtime and kubeproxy. Let's check out each of these components now. First component will be kubelet. So kubelet will run on every worker node in the cluster and its main job is to ensure all the containers in the nodes are running and functioning as expected. We can call it kubelet as an agent that runs on every node of the Kubernetes cluster. Let's see how it works. So first step is receive spot specs. The kube API server will send the spot specs to the kubelet. So these spot specs will describe what containers need to run and their configurations. Second step is schedule spots locally. So the kubelet ensures the specified containers are running on the node by working with the container runtime. The third step is monitoring the containers. So the kubelet will continuously check the health and status of the containers, and if a container crashes, the kubelet will restart the container. The fourth step is sends the status updates. Kubelet will report the health and status of the both node and pods back to the control plane. So kubelet is very important component, and without the kubelet, Kubernetes couldn't manage workloads on the individual nodes. The next component is container runtime. So container runtime is responsible for managing the containers in the node. Let's check out this in detail now. So container runtime will work under the kubelet to pull the container images, start the containers, and manage their lifecycle. Actually, container runtime is a software, and that will handle the low-level task of running the containers. Let's see the key responsibilities of container runtime. First one is pulling the container images. So it downloads the container images from container registries like Docker Hub, Nexus, or AWS ECR. Second one is starting and running containers. So container runtime will launch the containers using the pulled images, and it will ensure that they run as specified. Third one is managing container lifecycle. So it handles the container creation, starting, stopping, restarting, and removal of the containers. Fourth one is resource isolation. So it ensures the containers get the right CPU, memory, and storage without interfering with the other containers in the nodes. One is networking. So it will set up the networking for the containers. It will allow the container to communicate within the cluster and also externally. The last one is reporting status. So container runtime reports the status of the container to the kubelet. Then kubelet will send the update to the control plane. There are many container runtime softwares. The most popular is Docker. Other container runtimes are Containerd, CRI-O, Runc, and Podman. So in short, container runtime is the engine that runs containers in Kubernetes. The last component is kubeproxy. It is a network component that runs on each node of the cluster. So it is responsible for managing the network traffic, and it will ensure that pods can communicate with each other and with the external clients also. Let's see the key responsibilities of kubeproxy. First one is service networking. The kubeproxy will help to implement Kubernetes services by managing the network rules that route traffic to the appropriate pods. Also, it ensures that traffic is directed to a service is load balanced across the healthy pods. The second one is traffic route. So kubeproxy listens for the changes in the Kubernetes API server, and it will adjust the node's network rules accordingly. Also, it routes the incoming traffic from external clients or other pods to the right pods. Next is pod-to-pod communication. So it enables the seamless communication between the pods running on different nodes in the cluster. Fourth one is service discovery. So kubeproxy works with the DNS add-on, and it ensures that services can be accessed by their DNS names. So in short, kubeproxy is the traffic manager in Kubernetes, and it will ensure the smooth communication within and outside the cluster. So that's it. This is the architecture of Kubernetes. We have two planes, control plane and data plane. In control plane, we have kube API server, scheduler, control manager, and etcd. And in every node, we have kubelet, container runtime, and the kubeproxy. That's it for today. Subscribe and check out other videos too.